Assalamu alaikum. In this video I'm going to show you how to use Snell's law to determine the refractive index of a transparent medium such as glass or perspex. Now, in order to carry out this experiment you require a ray box, which is your source of light, a power supply to power up the ray box, a single slitted filter, ideally the thin slitted filter because that drastically improves your accuracy in your readings. I'm going to stick with a thick slitted filter just because that's a bit clearer and more visible in the video. A rectangular perspex or glass block, and of course a protractor, a sharp pencil and your ruler. Now, before you begin the experiment, first of all, place the perspex block or your glass block on the paper and draw an outline using your sharp pencil around that block. And the reason you do this is that later on, when you remove the glass block in order to draw your ray diagram, to complete that ray diagram, well, you'd be able to replace the glass block back to its original position. And of course, if you accidentally move it later on as well, somewhere during the experiment, you'd be able to put it back to its original position. Now, so place the glass block along the outline that you've just drawn. Remember, you're only allowed to change one variable at a time. So if you started your experiment with the glass block or your perspex block, make sure you use the same block throughout the experiment. Right, so power up the ray box. The ray box now produces a single beam of light, a single ray of light, so it passes through the medium. Now, when you've placed the glass block along the outline that you've just drawn, mark a point along the boundary, doesn't matter where, which will be the point where you consistently shine your ray of light. And of course, because you're only allowed to change one variable at a time, in our case it's going to be the angle of incidence in air, using our ray box of course. So you need to be consistent with all the other variables, which are the control variables throughout the experiment. So mark a point and use your protractor or a set square to draw a normal at 90 degrees to that point. I'm going to use a set square. You can use a protractor instead as well. They're equally good. So using the set square, I'm going to mark the normal at 90 degrees to the surface. This is going to be the point where I'll be shining or focusing my light. And there we go. So replace the glass block back to its original position, of course. Make sure that you take all readings and you draw all drawings from 90 degrees from directly above the paper in order to avoid parallax error. And you're ready to begin the experiment. So place the ray box onto the sheet of paper, and I'm going to start by shining the ray of light directly along the normal itself. Therefore, the angle of incidence in this case, the angle between the normal and the ray of light in this case is 0 degrees. And so you can also see that the ray of light travels straight on. It doesn't really bend as it passes through the medium. So because the angle of incidence is 0, the angle of refraction must be 0 inside the glass block. And as this ray of light inside the glass block then becomes incident along the glass to air boundary, again the angle of incidence is 0, and so the angle of refraction back in air is also 0. Now, as we increase the angle of incidence, so as the angle between the normal and the incident ray right here increases, so you see the ray of light starts to refract. And as you increase the angle of incidence further and further and further, the angle of refraction also increases further and further and further. So you can literally see the ray of light as it approaches the glass block and bends inside the glass block and then carries on parallel to its original incident ray as it emerges out the other end. Now, because we need to use our protractor and we're going to have to remove the ray box, we can't really use the ruler and the protractor effectively with the ray box on. We're going to have to mark 2 points along the incident ray using our pencil that we can later on connect using our ruler to trace the incident and the emergent rays of light. Okay, so switch off the ray box and use your ruler to connect those points in order to draw the incident ray and the emergent ray. So here's the incident ray along with the angle of incidence, of course, inside air. And of course you've got the emergent ray as it leaves the glass block at the other end. Complete that. Here's the emergent ray. You can use a set square or your protractor again to draw the normal along the boundary at that point. So here's the normal. And use your ruler to complete the ray diagram. So the ray of light must have travelled through the glass block between the 2 rays that you've drawn. So therefore you can trace the ray of light as it must have travelled through the glass block as well. So the angle of incidence between the air to glass boundary is the angle of incidence, or the angle between the normal and the incident ray. We don't really care much about the angle between the incident ray and the surface of the medium. We don't really care about that. Similarly, the angle of refraction inside the glass block is the angle between the normal and the refracted ray. We don't really care much about the angle between the surface and the refracted ray. And similarly, the angle of incidence again at the glass to air boundary this time is, let me just complete the normal. Make sure you're using a sharp pencil. Make sure all your things are drawn accurately. Right, so the angle of incidence again is the angle between the incident ray, this time the ray of light is travelling from glass back to air. So the angle of incidence is the angle between the normal and the incident ray. Again, we don't care much about the angle with the surface. And the angle of refraction between the glass to air boundary is the angle between the normal and the refracted ray. Again, we don't care about the angle between the boundary and the refracted ray. So therefore, you've got a complete diagram that shows a ray of light incident to the glass block and refracting through it. Now, to determine the refractive index, we can use Snell's law, which states that the refractive index is equal to sine of the angle in air divided by sine of the angle in the medium. With the incident ray along the air to glass boundary, the angle in air happens to be the angle of incidence, and the angle in the medium happens to be the angle of refraction. Therefore, between the air to glass boundary, the refractive index can be calculated as sine of I, sine of the angle of incidence, divided by sine of the angle of refraction. So, you can use your protractor to measure the angle of incidence in this case. So, sine of that divided by, again, use your protractor to measure the angle of refraction. So, sine of angle of incidence divided by sine of the angle of refraction. And you could repeat the experiment with other angles of incidences as well. So you could shine your light at increasing or decreasing angles of incidences and trace the rays of light and measure those angles of incidences and angles of refractions to determine varying refractive indices, values of refractive indices, and you could take the average for that. Or you could simply draw a graph of sine of the angle in air along the vertical axis and sine of the angle in the medium along the horizontal axis. And in this case, the gradient, which is the vertical divided by the horizontal, would turn out to be the refractive index. Anyways, thanks for watching.